right, so we're back. Let's go ahead and continue. So let's still let gx be the inside function and f of g be the outside function. So the inside function, again, I'm just going to use what's in parentheses here, 35x, and then the outside is just going to be ln of g. Well, that makes g prime of x pretty easy, as well as f prime of g. So derivative of that's just 35. The derivative of that's just 1 over g. So df dx is equal to what? Well, 1 over g times 35. What is g though? That's 1 over 35x times 35. Well, guess what? 35 cancels 35, and we get 1 over x is going to be our derivative. Okay, so that one turns out really simple in the end. Not much to do. Those things cancel, and we just get 1 over x. All right, what about the next one? Okay, well, remember when we have e functions, this whole thing is what we're going to call our inside function. So we'll have gx is equal to 0.6x, and f of g is equal to 72e to the g. All right, well, we continue on as we've been doing. G prime is going to be what? Well, that's just going to be 0.6. Derivative of that's just going to be 72e to the g. Because now that we're in e to the g form, that's derivative is just itself times 72. So now we have df dx is equal to what? Well, it's equal to 72e to the g times 0.6. Maybe we put that one in parentheses. Now, e to the g, well, g is 0.6x, so we'll take, okay, well, now we also have a 0.6 times 72, so 0.6 times 72, okay, that's 43.2. Then e to the 0.6x, okay? And then that's going to be our final answer because we just took this times this, and then we replace g with our 0.6, and that gives us our final result. All right, here again, what are we going to do? Well, I think I'm going to take the whole exponent is going to be my my inside function. So that's going to be my g of x is equal to ln of x. And that means f of g is going to be 2 to the g. Okay, well, that gives me g prime of x is equal to what? Well, the derivative of ln of x is just 1 over x. And the derivative here, 2 to the g, that's just going to be ln 2 times 2, maybe we'll put it in parentheses, to the g. Okay, so when we don't have the e, you have to take it in. So remember, when we have something like b to the t, we have to take ln of b times b to the t. So that's why we have this. Now we're going to take and find df dx, and so that's going to be ln of 2 times 2 to the g, and then times 1 over x. Now we need to get rid of that 2, or the g rather. So ln of 2, and then times 2 to the g, which is ln of x. And then all over x, basically. That's how I'm going to write it, just because 1 over x times that. So ln of 2 times 2 ln of x, and then over x. And then that would be my final derivative. And again, all we had to do is replace that g. And then I put the x in the denominator instead of leaving it out to the side there. All right, what about the next one? Well, here, when we have signs, remember that's what we're going to take for the inside function. And so that leaves our f of g equal to 3 sine g, and then plus 7. And maybe I need to make it better, not a sing, and I need sine g. It still looks like sing, but that's okay. So now we need to take those derivatives, g prime of x and f prime of g. Well, the derivative of this is easy. That's just 2. Now the derivative of this is going to be 3. Now the derivative of sine is what? It's cosine, and it's of g. Okay. Now df dx equals 3 cosine, well, now it looks like cog g, cosine g, and then times 2. Now, well, we can take 2 times 3, so that's going to give us 6. Then we have cosine. Now, g is 2x plus 5. And so then that would be my final derivative. Again, I just took that 2 times the 3 to get that. Okay. All right, so let's stop there. We'll come back for some application.